My name is Glen Riley. I'm Plastics Engineering Supervisor at Schweitzer Engineering. So we use science, technology, engineering, and math in plastics engineering. We work with thermodynamics. Plastics is a variable viscosity material. We calculate pressures and temperatures required to fill the part, and we calculate how far the plastic will flow and prior to building a mold and building a part so that we know we'll be successful. My education is primarily a plastics engineering, which goes over the material science aspects of plastics. It's a certificate type. Went to University of Massachusetts and obtained that. Immediately after college, I actually started in the mold setup and maintenance field, where I would do the routine maintenance on the molds and was in training for process engineer. Architect and engineering kind of go hand in hand. Architecture alone can involve things like air handling, air change calculations, water runoff, thermal rejection, those sort of things. But when you start adding things like a crane, an area that may require a separate mechanical analysis, I think that they have to be. At some level, every architect knows their boundaries, and the longer and more experienced they are at what they do. They are very similar, and their duties do cross over slightly, meaning that there are several structures that may need load calculations in a building. Snow loads, wind resistance, earthquake resistance, those sort of things could be tasks that both mechanical engineers and architectural engineers would be asked to calculate. If there wasn't enough collaboration between the different groups, you could have improper water drainage, flooding situations. You could have snow collapsing buildings, you could have earthquakes knocking them down. That is one of the factors that they consider. We're considered an earthquake zone. In our case, we have cranes. Even though it is the architect that specifies the air conditioning load, it's the mechanical engineering that's got to support it all from the roof. We do a lot of math in the design and engineering for our plastic injection molds. Plastic shrinks. We have to calculate which direction that plastic's going to shrink, because we actually have to build the mold bigger than the plastic part, because when the plastic cools off, it shrinks, and then somewhere between 6 to 20 thousandths per inch, depending on the type of plastic. There's a significant amount of geometry that goes in with molds. There's a lot of moving parts and side actions that need to be calculated. Trigonometry and geometry are two of the things that we have to do in the mold making area. In the plastics area, we have to, at least in my area, you have to understand some CAD systems, some SolidWorks. You have to be able to create a mesh out of a solid file. You have to do surface modeling, solid modeling. Depending on the problem, if I relate it to my job, there's some industry experts, application engineers for plastics that would occasionally were asked for a specific chemical resistance or a UL. Occasionally rely on some of our equipment manufacturers for engineering. And I also work with some colleges and some professors, work together to solve some issues on occasion. Detailed and focused, you have to be able to, don't get frustrated, basically. You got to be patient. But most of all, you have to carry those skills that allow you to complete the task completely and thoroughly. A good engineer basically is one that can use his skills that he's learned in school and willing to learn the skills that are required for the job.